Hello and welcome. In this video, we'll be discussing how we can use simple linear regression for prediction in R. To start with, I'm going to load up my data set as before, the X and Y. I'll only need the X bar, the mean of X this time. I'll have my linear model saved as SLR mod, the intercept and slope, and then I'll have P, N, and S. Remember S, the shortcut built-in way we could do is sigma SLR mod to find S quickly. And I'll be using all of this in my calculations for the prediction and confidence intervals when we get to that point. So all of this is going to be what I need. And once I have all this, I can go on and get started with basic prediction. So remember with basic prediction, we had X star, and I guess I'll just write X star. I can't put a star in the variable name because remember star in R means multiply. So it won't know, am I saying X star as a variable or X times something? So I'll just write the word star. In my case, for our basic prediction, remember we had this super duper basic model, X star. And so if I want to predict a new value for Y, say Y star, I would take my B0 plus B1, and then I would put in my X star value. And this would give me a Y star, or a predicted outcome for this predicted input. All right, so let's go on and start building confidence intervals and stuff by hand. So let's go on and start with the by hand calculations here. So I'm going to do a different X star. I'll do X star is 8 because that's the one we did in the example, the next example in the notes. Y star, again, I just take this value, plug this in with my appropriate B0 and B1, and that gives me Y star. And I'll probably need to save this because I'm going to be using this. So I'll copy and save that, Y star. Awesome. And so now whenever I say Y star, that is the predicted Y for the new X value. So maybe I could call it Y hat star if I wanted to, I guess. Maybe I will do that just so that we're keeping, I'll just call it Y hat underscore star. So we're keeping it straight. This is the predicted Y for that value. Y hat star. Cool. All right. Okay. So now I need to do my standard error calculations. So if I'm doing a confidence interval for prediction, I need my S sub Y hat. I'll just call it YHS, Y hat star for this one, because that just gets really long. But my S with the little sub Y hat and then the star in there. That's what this guy's going to be. Remember, I need S. This is that S from above. And if you want to see where all this comes from previous videos. So we manually made all these in previous videos. If you want to go see where those come from, we had, I believe it was in the inference video where we talked about how to calculate S by hand. We're using the shortcut here, or the built-in function here. But for the Y hat star, I need that S value times, and then this is the square root, and I'm just looking at my notes here, 1 over n plus X star minus X bar all squared. And then that's going to be the numerator. The denominator is going to be the sum of X minus X bar squared. And again, we're squaring inside the sum. So this is the squared part. And then the sum is outside of that. So we do X minus X bar. And I had a typo there, X minus X bar, wrap that in parentheses. We square after we do X minus X bar, and then we sum after we square it. All right, so that is my standard error for the confidence interval for prediction. All right, so for my standard error for the prediction interval for prediction, we had S, and we called this S sub pred. So I'll use the underscore to indicate sub, I guess, here. So S sub pred. And we had essentially, we copy and paste the exact same thing, I promise, or you can retype it all if you want. And the only difference is inside the square root, we had a 1 plus. That is the only difference between the standard error for the confidence interval for prediction which we denote S sub y hat star, and the standard error for the prediction interval for prediction. The only difference, I copy and paste them. The only difference is in the square root, I add this little 1 plus. That's it. And now I have my standard errors for the confidence interval for prediction and the prediction interval for prediction. To do this, I'm going to need my building the intervals. And I'll build both, but you know, if you're only asked for one, you only have to do one. So just use whichever one is appropriate for your case. Here I'm just showing how we can build both. So for this, I'll need my starting place. So remember, in this case, my starting place is y star, my point estimate, plus or minus my critical value. So I guess I haven't found my critical value yet. See, I got to follow along with my notes a little better. And that happens sometimes, y'all. You get done, you're like, oh, wait, I did CV here, and it's going to give me an error. I don't know what CV is. So my critical value is going to come from a t-distribution, QT. I'm going to have my, let's see, so my alpha level, I'll just use 0.05 over 2. My degrees of freedom is my degrees of freedom error, but I actually don't have that variable made. I can do ls open parentheses and close parentheses to see what all my variables are. And I don't have these are in alphabetical order. I don't have a df e here. I don't have any degrees of freedom variables made. You can also look in the environment and it gives you the list of all the variables you have. So I don't have any of that made. So instead of using a pre-built one, I'll just write n minus p minus 1. Remember, that's the equation for the degrees of freedom for the error. And I do have n and p. Otherwise, I'd just type the number 5 if I wanted to. And then again, for my intervals, I like doing lower tail equals false because this gives me the positive one. And then I'll do the plus and minus later on. So I got to save that as my critical value, and now I'm ready to build the intervals. So y star plus the critical value times the standard error. So remember, for the let's build the confidence interval for prediction first. So for this confidence interval for prediction, critical value times the standard error for the confidence interval for prediction, which is y hat star. So this is my, oh, did I not save that? I guess I didn't. There we go. This is my top part of the interval for y hat star, the confidence interval for prediction. Then I'll subtract. This is the bottom part. So negative, or excuse me, positive 0.91 to positive 3.35. And that's my confidence interval for prediction. And again, remember, that's the interval for the mean. So if I'm predicting this and I'm trying to figure out on average what's going to happen if I invest $8,000 in marketing over and over and over again, on average, it's going to come out between, say, $1,000 and $3,300 in terms of profit if I did it over and over and over and over again. All right, what about the prediction interval for prediction? So for the prediction interval, remember, this one is talking about what happens if I do it just once. I put in $8,000, what should I expect to see with 95% confidence? So it's going to look the same. Again, I start at the same spot, the y star. That's my best guess as to what's going to happen. So my best guess is you make $2,000 for both of these intervals. Actually, that's still my best guess. But now we're adding on that buffer zone, and the buffer zone for the mean, when you try it a whole bunch of times, is much smaller than the buffer zone for an individual try. So I use S sub pred. This is my standard error of prediction, and I do the plus and minus, and then I'll run these two, and I get a wider confidence interval. So for a single time when I invest $8,000 in marketing, I expect with 95% confidence to either lose up to $1,300 or to gain up to $5,600. So there's a lot more variability when I'm just looking at one investment versus the confidence interval for prediction, which, remember, was the investment over and over and over again. All right. And yeah, that's it. That's doing it by hand. Yay. All right, let's look at the built-in functions. So for the built-in stuff, we use the predict command. Now the predict command is fantastic, but it has a bit of weird notation. So let's get into it. So I'm going to do predict. And then I'm going to give it my model. So remember my regression model I called SLR mod. And now to predict new values, actually predict, if I just did this, this gives me all of my y hat values. Do I have y hat on here? No, I don't have y hat. So this gives me all of my y hat values. And I see, actually now that I'm noticing this, I used a y star down here. So y star was the other notation I had for my y hat star. So if that confused you, I'm sorry. But just realize those are the same numbers. So be aware. I typed a y star and ran it and then said, oh, I should do y hat star. That's the risk. I made two variables, one of which I no longer have code for up here. So just be careful that you're using consistent stuff. For me, I should probably change this to be y hat star because that's the notation I used above. Anyway, all of these are my y hat values. So for each one of these are my y hat values for each data point. So that's interesting. But for us, we're talking right now about predicting new values. And so to do new values, I'm going to use the predict command and then do new data equals. Now, the weird thing is, again, regression in R is built for a bigger thing than simple linear regression only. So what R is going to look for is observations, and it's going to look for the new data in a form such that you could potentially have many new variables. So if I had multiple regression, I might have 5 variables that I need to provide the new data values for the prediction. In this case, we only have 1, but again, R is built for that bigger thing. So what I'm going to do is do data.frame, open parentheses, and then I'm going to provide the name of my variable. So if I look at this SLR model, the name of my variable is marketing. So right here, I'm going to write marketing equals, and then whatever that new value is, in this case, 8. And then I'm going to copy and paste that over, Control Enter, and run that. So if I have multiple variables, I'd have to list them all. Marketing equals 8, comma, sales equal 5, or whatever, within these data frame parentheses to be able to run that. And again, for simple linear regression, we don't have to worry about that as much. But when we get to multiple linear regression, we'll have to take care of that. I could also, if I wanted to do a whole ton of predictions at the same time, give it a vector of numbers, and it would do a whole ton of predictions at the same time, which is kind of fun. All right, so how do I do prediction and confidence intervals? Well, that's a good question. For the prediction interval, I will give it the interval command, and for the confidence interval, I'll give it the interval command and just type in confidence. So interval equals quotes confidence. Be sure that you're doing this outside of the data frame. So the data frame, do marketing equals 8, and then close that parentheses there. And then you're going to do a comma inside of the predict statement, and then you'll add the interval equals confidence with confidence in quotes. And hopefully you get something like this, which is hopefully my confidence interval. This one, confidence interval for prediction, 0.91, there we are, to 3.35. Fantastic, my confidence interval for prediction. I'll copy and paste that, and to come up with a prediction interval, just replace the word confidence with the word predict, and that'll give me a prediction interval instead of a confidence interval. And again, if I compare that to my prediction interval with fingers firmly crossed, I get the exact same numbers for my prediction interval that I calculated and the one that R is coming up with, which is good. That means I did it right. That'd be awkward. If I wanted to do something other than a 95% confidence interval, what these provide by default, as before, I can, I'll just copy and paste here and change the level of this. So in this case, it's not called conf level, it's just called level. And I do say 0.9 for a 90% confidence interval, or 0.8 for an 80% confidence interval. You'll note that in the output, R doesn't actually tell you what confidence interval it used. So if you want to be sure you're getting a 95% confidence interval, you can provide level equals 0.95 to make sure this is a 95% confidence interval. You'll see when I didn't include level at all and left it at its default value, the numbers match the numbers that I'm getting when I'm explicitly telling 95% confidence interval, which tells me that the default value is 95%, as with most other things in R. So in any case, this has been how we do prediction for simple linear regression in R. We talked about how to do some basic prediction, how to build up our standard error for the confidence interval for prediction, how to build up the standard error for the prediction interval for prediction, and then how to use both of these to actually create the intervals. Finally, we covered how do we do the built-in tests in R, which had this weird data frame thing, but once you get the hang of it, makes calculating confidence and prediction intervals really, really easy. All right, team. Well, thanks for sticking with me through this video, and I will look forward to catching you in the next one.